Hello and welcome to another video. Today we are going to be speaking about limits and the rules that apply to them, the rules with which we play the game. So, we can only evaluate the limit of a function if our function is continuous. When is our function continuous? So our function is continuous if the domain does not have any gaps or holes in it. So let's say that we have the function y equals x. Domain is all real numbers, and basically our function is continuous. We don't have any gaps or any other spoiled points. If we have another function, let's say that our function sort of has a gap here, and then it starts here again and continues into infinity. Now, if this point is 1, how would you evaluate the limit at this point? How could we? Is it even possible? So the problem here is that if we approach it from the right hand side, so if we approach the value 1 from the right hand side, we get, let's say this is value 2. But if we approach 1 from the left hand side, then we get the value 1. So our limit from the right hand side does not equal the limit from the right hand side. Does this mean our function is continuous? No, it doesn't mean it's continuous. It doesn't continue. Imagine a line. If a line is continuous, or let's say a piece of string, it doesn't have any sort of breaking points. It just doesn't stop. It continues going. So it's kind of similar to a piece of string in that if it doesn't have any tears or if it's not split up into small parts. So we have a function that looks like this. Again, we have two different points with we have the same point and two different values for that point. So our function is not continuous. Then we have these kind of weird functions where we have an asymptote. So we have an asymptote at point 1. And if we want to evaluate the limit, we can't really, because as we approach from the right hand side, so I'll write that down, as we approach it from the right hand side, we just head into plus infinity. So the limit of our function f of x, let's call this function f of x. And here if we approach it from the left hand side, so the limit as approached from the left hand side of our function is going into minus infinity. So we have two completely different values, and therefore our function is not continuous. Again, imagine a piece of string. Is this piece of string continuous? Not really, it's broken into two pieces. Is this piece of string continuous? No, it's broken into two pieces. So, is this piece of string continuous? Yes. Is this piece of string continuous? Y equals x squared. Imagine that this goes into infinity. It is continuous. Our domain does not have any points where it is not continuous. It's all real numbers. Now, I'll just scroll down. We have different tricks on how to evaluate limits. Obviously, if we can't evaluate them, we don't. So we say a limit does not exist. Or we could just write our limit of our function x as x approaches some points does not exist. Or we can write this symbol here. Now, if our function is continuous, and doesn't have any sort of breakage points, can we evaluate the limit then? Yes, we can. We can evaluate it, and we can evaluate it at several different points. And the core idea is this. So imagine I'm approaching the point 2. From the left hand side it's going to come to 1.9. I'm going to come to 1.98, then to 1.999, and to 1.9999, and I'm going to get closer from the left hand side. And then from the right hand side, which value am I going to have? I'm going to have 2.01, now 2.0001, 2.00001, 2.00001. It's a lot of zeros. So this is approaching our point 2 from the right hand side. This is approaching our point 2 from, left hand side, and this is from the right hand side, as denoted by the different signs. So from minus infinity and from plus infinity. Now, if I asked you, what does our limit approach in the point 2? It would be of our function f of x. That's our function, f of x equals x. Just plug in the value and it's 2. But what we're trying to show here is that from the right hand side we're getting a number that is getting close to a certain number, in this case 2. And from the left hand side we're approaching a similar number. So from both sides we're approaching the same number. It's not like we're approaching from the right hand side number 3 and from the left hand side we're approaching 1. That wouldn't work out. But if we're approaching 1.999 and 2.0001, we can safely say that we're approaching the value 2 of our given function. Again, our limit does not mean that we actually get to this point. We get infinitely close to this point, which is basically a fancy way of saying really, really close. How close? Really close. That's the answer you'll get from a lot of mathematicians. So, to recapitulate, we're approaching a point, our function has to be continuous. Those are the rules of the game. Thanks for watching again. Please like, comment, share and subscribe, and see you later.